We can also use definite integrals to find the area between curves using functions of y. So suppose this curve is y equals f of x, and this is another one with y equals g of x. And we choose rectangles parallel to the horizontal axes, which have an infinitesimal thickness dy. So to integrate with respect to y, we need to write x in terms of y. So what you do is solve for x, and you'll get x in terms of y. So for example, u of y, and here you'd get x is equal to v of y. And therefore the width of this rectangle is v of y minus u of y, and then multiplying by dy gives the area of that infinitesimally thin rectangle. And then integrating from y equals a to b is effectively summing up the areas of those infinitesimally thin rectangles from a to b. And that gives us the area of this region. Let's find the area of the region bounded by the curves y equals x squared and y equals root x over the interval from 0 to 1. And we're asked to use rectangles that are parallel to the x-axis. So these are horizontal rectangles that are going to have an infinitesimal thickness dy. And to obtain the length of that rectangle, we need to write these equations for these curves in terms of y, because we're going to integrate over y. So x is effectively equal to y squared, and for this case, x is equal to y to the 1/2. And the parabolic curve lies to the right of the square root curve, so we use y to the 1/2, and then subtract y squared to obtain the length of that rectangle. And multiplying by dy gives the area of that rectangle. And we integrate from y equals 0 to y equals 1. So this basically sums up the areas of those infinitesimally thin rectangles to give the area of the region. And you can easily evaluate this integral and compare your result with the previous video, where we used the vertical rectangles instead. Let's find the area of the region between this curve, which is a square root function, and the line y equals minus x plus 1, which is going to look something like this. So it intercepts the x-axis at 1 and the y-axis at 1. So to avoid evaluating the integral piecewise, I'm going to select horizontal rectangles, which have a thickness of dy, and therefore we should write the equation of the curve and the line in terms of y. So we have x is equal to 1 minus y. And the line is to the right of the square root curve, so what we do is subtract y squared from 1 minus y. And that's going to give us the width of that rectangle. And then multiplying by dy gives us the area of the rectangle. And we integrate from y equals 0 to the y coordinate of the intersection point between the line and the curve, which I'm going to call a. And that's going to give the area. And now to find a, what you can do is equate these two equations together, solve for y, and then you can find a, perform the integration, and post your answer in the comments.